Buckle in, everybody. We're going to take a deep dive into Saharan dust. Why is it so important to us? Why is it so important to weather across the Atlantic Ocean? And also some technical stuff about why it comes here in the first place. How does it get blown all the way across the Atlantic Ocean? This is a look at the latest plume of Saharan dust that is going to be a pretty big deal across the Caribbean Sea and across even parts of the USA here over the next couple of weeks. And this is a look at the projection of the thickest plume of moisture coming toward the Houston area on Monday. It should be very noticeable, giving a brown tinge to the sky and even affecting our weather here locally. A lot of times it can inhibit the formation of thunderstorms if we get a thick layer of it. And in fact, it could spread across much of the country. So this thing is traveling thousands of miles, this plume. How far is it coming from? Well, approximately 5,000 miles. This is 4,896 miles, let's say, from Galveston all the way back over to the west coast of Africa. So how in the world does it travel this far? Let's take a look at it. And for that, I want to take you over here to Africa, where we can get a sense of what drives all this, okay? So this is the Sahara Desert. I have moisture levels on here, and I think you can imagine the green is where there's a lot of moisture, and the brown is where there's not very much moisture at all. Well, this is the Sahara Desert. The Sahara is the largest hot desert in the world. Why do we say that? Because Antarctica is actually the largest desert, but this is the largest hot desert in the world, and obviously it gets extremely hot. It's kind of the type of weather you'd get in Phoenix or in Death Valley, California, and those types of things. Now, this area right here, where you see the green, is called the Intertropical Convergence Zone. What is that? Well, during the summertime, you have storms that would be at the equator. They move a little farther north, and you end up with the rainy season here in this part of Africa. You've probably seen that in different documentaries about wildlife out there in Africa where they wait for the rainy season, right? Well, this is that wet season or rainy season across that part of Africa. And so this is what gives us our tropical waves that move off the coastline. But why does it head our way? Well, it's some unique geography that we have over there in Africa. So between the very hot and very dry air here and the warm, really humid air to the south of it, you end up with this front that's called the Intertropical Front. And it separates the Saharan air from this extremely humid air that's here along the coastline. So you have storms that form along this boundary. These storms kick up dust from the desert. It's kind of like when we talk about dust storms in Arizona, or maybe in West Texas, you'll get dust storms, and that dust can get carried up into the air. Sometimes the dust even ends up around the Houston area. So that's part of what is driving the dust entering the air in the first place. We also have this unique setup because of the shape of the continent of Africa. You just happen to end up with the hottest desert in the world here to the north of a relatively cool body of water, being the Atlantic. So I have some numbers here. The water temperature here is about 82 degrees, and then the desert might be 110 or something like that, 115 degrees. So you have the difference between cool to the south and hot to the north. That's exactly the opposite, by the way, of what we get in the United States. It's colder to the north, it's warmer to the south, and so you have a jet stream that blows from California to New York, basically west to east. Well, this reverses that. It makes a jet stream blow from east to west, and that's what blows the dust all across the Atlantic. So the dust gets kicked up into the air by thunderstorms. It gets carried on what's called the African easterly jet into the Atlantic Ocean. Okay. So then what? Well, it's important to us because it tends to inhibit the formation of hurricanes or tropical storms. Why would that happen? Well, two reasons. One is that it's dry air because it comes from the desert, and you need warm, humid air to create those tropical systems. But there's one other wrinkle you may not have thought of. All of this is very high up in the atmosphere, several miles up. Well, the sun comes in and it actually hits these particles in the atmosphere, these pieces of dust in the atmosphere and microscopic sand actually in the atmosphere. When the sunlight hits it, it actually warms it up. Just imagine walking on the beach. You know how you got to wear flip-flops or something because it gets hot. Well, it actually warms them up above the ground, and when you have hot air that's above the ground and then slightly cooler air at the surface, we call that an inversion. and it puts a stop to any tall clouds that would try to form. So it's a really complicated, but I think a pretty amazing scenario here that carries dust and sand 5,000 miles across the Atlantic Ocean, and you'll be able to see it in our sky here over the next couple of weeks.